Our first task is to learn how to switch coordinate systems. So if we're given the polar coordinates of a point, how do we find the Cartesian coordinates and vice versa? This is a very important thing to learn, and it's something you'll do a lot more of in Calculus 3. So suppose I have the polar coordinates for a point on the plane r theta, and I want to switch to Cartesian coordinates. Then since this point lies on a circle of radius r, and the angle that a ray from the point to the origin makes at the positive x-axis is theta, we can see that the x-coordinate has to be r times cosine theta, and the y-coordinate has to be r times sine theta. And we can see this from the triangle below. We have cosine of theta is x over r, and we have sine of theta is y over r. So suppose I want to convert the following points given in polar coordinates to Cartesian coordinates. So the first point has r equals 2 and theta equals pi over 4. And the x-coordinate must be r times cosine theta, which is 2 times cosine pi over 4, which is 2 over the square root of 2, which is the square root of 2. And the y value must be r times sine theta, which is 2 times sine pi over 4, which is also the square root of 2. So the Cartesian coordinates for the first point are given by x equals the square root of 2, y equals the square root of 2. For the point given in polar coordinates as r equals 3, theta equals minus pi over 3, we have Cartesian coordinates x equals r times cosine of theta, which is 3 times cosine minus pi over 3, which is 3 times 1/2, which is 3 over 2. And the y value is r times sine theta, which is 3 times sine minus pi over 3, which is 3 times minus the square root of 3 over 2, which is minus 3 times the square root of 3 over 2. So the Cartesian coordinates for this point, in polar coordinates it's given as 3 minus pi over 3, and in Cartesian coordinates it becomes x equals 3 over 2, y equals minus 3 times the square root of 3 over 2. Now suppose I want to go the other way. Suppose I'm given the Cartesian coordinates of a point and I'd like to find the polar coordinates. The r value is going to be the distance from the origin, so we know that r squared is x squared plus y squared. And also if I draw a ray joining the point to the origin and I note the angle that that ray makes with the positive x-axis, I see that tangent of theta equals y over x. So therefore the theta value for the polar coordinates must satisfy this equation. Since tangent is not a one-to-one function on the angles from 0 to 2 pi, we must figure out which quadrant the point is in before we can figure out what the value of theta is, because there are two angles with tangent of theta equal to any given number in the interval from 0 to 2 pi. So for example, suppose I'm given a point in Cartesian coordinates where x equals 2, y equals 2, and I'd like to find the polar coordinates. I know that the r value is the square root of x squared plus y squared, so that's the square root of 4 plus 4, which is the square root of 8, so r is the square root of 8. And we must also have tangent of theta is y over x, so tangent of theta is 2 over 2, which is 1. And I also know that this point is in the first quadrant, so I know that theta must be the angle pi over 4, because there's a unique angle between 0 and pi over 2 with tangent of theta equals 1, and that is theta equals pi over 4. If the Cartesian coordinates for the point are 2, 2, its polar coordinates are r equals the square root of 8 and theta equals pi over 4. Now suppose I'm given Cartesian coordinates x equals 1, y equals minus the square root of 3, and I wish to find polar coordinates. Then I have r equals the square root of x squared plus y squared, which is the square root of 1 plus 3, which is the square root of 4, which is 2. And I also know that tangent of theta is y over x, which is minus the square root of 3. And since the x value is positive and the y value is negative, I know that this point is in the fourth quadrant. And we have a unique angle between 0 and minus pi over 2, for which tangent of theta equals minus the square root of 3. And that is minus pi over 3. The polar coordinates for this point are 2 minus pi over 3. R equals 2 and theta equals minus pi over 3. And let's try one last example. Suppose I'm given Cartesian coordinates, x equals minus 1, y equals the square root of 3, and I'd like to find polar coordinates for this. Again, r squared is x squared plus y squared, which is 4, so r has to be 2. And we also have tangent of theta is y over x, which is minus the square root of 3. Now this point is in the second quadrant, so there's a unique angle between pi over 2 and pi, which has tangent of theta equals minus the square root of 3. And that angle is theta equals 2 pi over 3, so we have polar coordinates for this point are given by r equals 2 and theta equals 2 pi over 3.